Let's do this problem right here. The question is asking, is the set S is a subspace of R3? Justify your answer. So let's begin with the first question. Let's prove that. Okay, first of all, we have to know if something has to be in subspace, it has to satisfy three conditions. First, it has to be closed under scalar. First of all, it has to have a zero element, and the second condition is it has to be closed under addition. And the third one is it has to be closed under scalar multiplication. So these are the three conditions this has to satisfy. So let's go further and do it. So if you see, it has, first of all, it has zero element, because if you substitute 0 for everything, you will get 0 0 0, but it has satisfied the first condition. Next is closed under addition and closed under scalar multiplication. So what we can do is we can pick up the third one, because you can little bit think about it. It's not gonna be in the subspace, because x times y, if you see x times y multiply, you can intuitionally you know that it's not gonna be in subspace. But closed under addition is a little bit big step, so you can go to the closed under scalar multiplication, and if it's satisfied, then you can go to the closed under addition, because closed under scalar multiplication is much simpler. So let's do that. And if I do that, let's say if I take 1 1, let's say 1 1, I'm picking the random number, so 1 1 1 belongs to a subspace. So if we multiply, if that is true, what does this mean is, if you have three numbers, multiplication of first number minus the third number should be equal to 0. So that's the condition of this set. So let's do this. First two numbers, 1 1, multiplication of these two minus the third number, that's 1, equal to 0. It's true for 1. Let's check whether it's true for 2. If it's true, this should be true for all the numbers, right? So let's check whether it is true for 2. So if I say 2 2 2, pick up 2 2 2, and then if I do the same thing for that one, multiplication of first 2 minus the third one, does it give us 0? If you see 2 times 2 is 4, 4 minus 2 is 2, it's not equal to 0, therefore this is not 0. Therefore we can say this set, therefore set is, thus also we can say 2 2 2 does not belongs to the subspace, therefore set is not a subspace of R3. And let's do the B question. The B question, first condition, 0 element, same thing, 0 element, the closed under addition, and the third one is closed under scalar multiplication. So if you see this one is not x square y, not something like that, right? It's x minus, it's a line. So in this case, we are not very sure whether it is belong to subspace. So we have to, in this case, we shouldn't pick the numbers. We have to solve in terms of x, y, c, a, y, a, b, c, something like that. So let's check for the whether it has zero element. To check that one, I can substitute 0 for everything. We will get 0. Like if you substitute 0 for x, 2 times 0 minus 5 times 0 is equal to 0. It has 0 element. For this one, it's and for this one, it has 0 element. 0 minus 0 equal to 0. Therefore, we have 0, 0, 0. So we have 0 element. First condition is passed. Let's do the second condition. So what it says, let's pick up two numbers. If I say a, b, c, it's two, right? So a, b, just a, b. So a, b, let's say a, b belongs to subspace. If a, b belongs to this set, then this should be true. Multiplication of first value by 2 minus multiplication of second value by 5 should be equal to 0. Therefore, 2a minus 5b should be equal to 0. And let's pick up another number. Let's or you can bring the same numbers like xy. Same this alphabets. Xy belongs to s. So 2x minus 5y should be equal to 0. So if this is true, when we add them together, I'm doing the closed round addition proof. So if I add them together, ab plus xy, a plus x, b plus y, add them together, this condition should be true for the addition proof. For example, the first value, 2 times ax, 2 times a plus x, minus 5 times b plus y should be equal to 0. Let's check whether it is true. If I multiply this one, 2a plus 2x minus 5b plus 5y minus 5y is equal to 0. And I can rearrange this one like 2a minus 5b plus 2x minus 5y equal to 0. Now what I can do is I can substitute these values. You see it's the same value right here. So if I bring this one, it's 0 right here, plus 0 equal to 0. This means this is closed under addition. And if it's closed under scalar multiplication, what do you have to do? We have to do the same thing for the multiplication. Let's see. So I'm continuing right here. Okay, I'm picking up the third condition, closed under scalar multiplication. Let's pick AB. AB belongs to S, and we are picking a constant. Let's say K. K is all real. Any can be any real number. So in this case, what I have to do is, first of all, we know that if AB is in the subspace, it should be the multiplication of 2 by first value minus multiplication by 5 by second value, and if you deduct them, that should be equal to 0. So 2a minus 5b should be equal to 0. And let's see whether it's true for the multiplication. So if we multiply AB, we will get KA, and KB, right? And if I do the same thing for this one, like 2KA minus 5KB, is it true? Like, will it be 0? Let's check. What I can do, I can take the K common, 2A minus 5B equal to 0. And if you see, this is the same thing, and I can substitute here. That means k times 0 is equal to 0, therefore 0 is equal to 0, which means this is closed under scalar multiplication. Therefore this passes the third condition. Therefore we can say, therefore this is this set is the subspace of R2, and that's how we prove these kind of questions. I hope you guys like this video. See you next time.